Okay, time to dive into some actual explanations of all of this. So, the biology of this whole time perception thing starts right here in the human brain. You see, our brains have specific regions that are responsible for processing and perceiving time. The prefrontal cortex, the cerebellum, and the basal ganglia. These areas work together like a finely tuned clock, giving us abilities like episodic memory, to recall past events, temporal prediction, to anticipate what's coming next, and interval timing, to gauge durations. Now, here's the catch. In animals with simpler brain structures, these functions don't operate in the same way. For most animals, time is all about instinct, reacting in the moment to survive. It's not about remembering when to plant seeds or plan a harvest. It's immediate and reflexive, not abstract. Of course, some animals excel in some of these areas, and I'll cover how that fits in a bit. This is where humans stand out. The development of the neocortex, particularly the prefrontal cortex, gave us a massive upgrade in cognitive abilities. It's this part of the brain that lets us think ahead, solve problems, and even create stories. Things like, if I don't plant these seeds now, I won't have food later. Or, I messed up this section last time and I should enunciate these words better. That ability to integrate time into larger narrative, to connect the past, present, and future in meaningful ways is what sets us apart. This neural complexity wasn't just an evolutionary side quest, it was the moment that we unlocked something huge, the ability to perceive time as more than just a survival mechanism. It became a tool, a concept, and ultimately the foundation for everything that we've built as a species. So now let's talk about the leap from living in the moment to planning for this future, a shift that fundamentally separates humans from other animals. Most animals perceive time in a present-based way, where survival depends on reacting to immediate stimuli. It's all about short-term cause and effect loops. Hunt now, eat now, run now. There's no real abstraction, no looking back to plan ahead, just instinct doing its thing. Even squirrels collecting nuts for the winter know to start doing that because of instinct, not because they looked at their calendar and saw that it was September and they should be stashing nuts. Early humans weren't all that different, at least at first. Like any other animal, they were tied to the present moment. But as our brains evolved, something incredible happened. We started developing episodic memory, the ability to relive past experiences and mentally time travel, which allows us to imagine and plan for the future. It's not just a cool trick, it's a survival game changer. Environmental pressures like seasonal cycles, food scarcity forced us to adapt. Those who could remember where food was last year or anticipate migration patterns had a massive advantage. Over time, this temporal awareness became key to our survival. It wasn't just about reacting to the now, it was about planning for the what if. From a quantum perspective, this shift represents a cumulative encoding of time information in the quantum field. Each species builds on this encoded experience over generations, adding to the collective blueprint of time perception in the natural world. With humans, this encoded knowledge reached a critical threshold, unlocking the first cognitive stage of our species, the ability to perceive and manipulate time abstractly. And this was the point where humanity began to truly differentiate itself from all other species. This ability to conceptualize time, to imagine futures, and learn from the past became our foundation for intelligence and innovation as we know it. And with that, we set ourselves on a trajectory unlike anything our world has ever seen. So, why did we make this leap into abstract time perception when other species didn't? The answer lies in the growing complexity of human society. As our answers began to form larger social groups, social coordination became essential. You couldn't just rely on instinct anymore. You had to plan for group hunts, stored food for the future, and build shelters that would last through the seasons. This required a shared understanding of time, where the past, present, and future became a collective framework for survival. The Sumerians exemplify how this reached its peak. Their calendars, seasonal tracking, and structured use of time weren't just clever innovations. They were tools for managing increasingly complex societies. You needed everyone on the same page, or at least the same timeline, to make agriculture, trade, and government work. Language played a huge role here too. While animals might give alarm calls for predators or signal food nearby, these are immediate, present focused communications. Humans, however, began encoding these temporal concepts into language. Words like yesterday, tomorrow, and later gave them the ability to discuss time as an abstract idea. This reinforced the cognitive framework for thinking beyond the now. The real advantage? Abstract time perception allowed humans to delay gratification and plan long term. Whether it was storing food for winter or aligning agricultural cycles with lunar phases, this ability to connect the natural cycle of time to abstract goals gave humans a massive edge. It wasn't just about survival anymore, it was about thriving. This shift wasn't accidental, it was the natural outcome of evolution meeting societal complexity, and it set the stage for everything that followed. So, why did we cross this threshold at exactly this point in our evolution? It comes down to hitting a cognitive tipping point. By the time we reached the Sumerian stage, our brains had already developed the capacity for abstract thought and temporal awareness. Early hunter gatherers likely had a basic sense of time, enough to anticipate migrations or track food sources, but they didn't need to formalize it. Life was more reactive, tied directly to environmental cues. That changed with agriculture. Farming required something completely new: the ability to think in long term cycles. Planting seeds, tending crops, and harvesting weren't, weren't tasks you could approach instinctively. They demanded months, sometimes years, of strategic planning. You couldn't rely on the immediate present anymore. Survival depended on aligning your actions with seasonal rhythms, which meant humans had to move beyond basic time perception to fully structured abstract time. The shift wasn't just about individual survival, it was about managing organized stationary communities. Agriculture tethered humans to one place, creating the need for record keeping, calendars, and eventually large scale coordination of labor and resources. That need for structure pushed us to formalize time into measurable units, something the Sumerians perfected with their meticulous tracking of lunar cycles and celestial movements. The stage of evolution represents the moment where human cognition truly separated from instinct and stepped into abstraction. Time wasn't just something we reacted to anymore. It became a tool, a system, and ultimately the foundation of civilization of itself. Let's dive into why humans perceive time the way that we do and how that ties into both biology and quantum theory. Biologically, our brains experience time subjectively, shaped by attention, memory, and emotion. But modern quantum theories suggest that time, as we perceive it, might be an illusion or observation, a construct emerging from how we process reality. This idea intriguingly aligns with how the Sumerians blended cyclical and linear time, which hints at a deeper connection between perception and the nature of time itself. Animals, by comparison, experience time through their survival lens. Creatures with faster neural and metabolic processes like flies perceive the world in slow motion, giving them split second reaction to advantages. Humans with slower processing evolved to view time in broader horizons, enabling us to plan, abstract, and project into the future. This wasn't just a biological adaptation, it's what allowed us to conceptualize and measure time on a scale that supports storytelling, agriculture, and even civilization. The Sumerians' timekeeping innovations, tracking celestial cycles and dividing time into structured units, reflect not just their ingenuity, but the culmination of this unique perspective. Their understanding wasn't practical, it symbolizes a shift from experiencing time instinctively to mastering it intellectually.